Okay, so welcome to this next video in which we are discussing the endoplasmic reticulum activated degradation pathway, or the ERAD pathway, which is a pathway basically for destroying proteins which have misfolded in the endoplasmic reticulum. So we've had our polypeptide misfold in the endoplasmic reticulum lumen. It is then fed back out into the cytoplasm through a translocon. Now, what we're going to discuss is how the lysine residues of this polypeptide are going to have ubiquitin proteins added onto them, basically. So, this ubiquitination process, as it's called, which is the process of adding ubiquitin onto proteins, it's a process that involves 3 different families of enzymes. So we've seen how it's going to involve this E1 enzyme so far, and what we've seen is that E1 has this thiol group, which has so far formed this link with the carboxylic acid group of the ubiquitin protein. Okay, now what's going to happen is the next hero in this story is going to come along, and the next enzyme that's going to come along is known as a ubiquitin conjugating enzyme. Okay, so ubiquitin conjugating enzyme is going to come along next, or a ubiquitin conjugating enzyme, because there isn't just one ubiquitin conjugating enzyme, there are absolutely loads of them, but a ubiquitin conjugating enzyme is going to come along, so an enzyme that's capable of conjugating ubiquitin. And again, someone long ago decided that ubiquitin conjugating enzyme was a bit of a mouthful, so we call them E2 enzymes. Okay, so in comes our E2 enzyme. So we will draw this E2 enzyme here, and I think we'll colour it in orange. So this is an E2 enzyme, or a ubiquitin conjugating enzyme. And basically, this E2 enzyme, it also has a thiol group. So I'll draw this here. Okay, so it's going to have a thiol group as well. So here's its thiol group. And what's going to happen, basically, is that the this ubiquitin that is currently bound to our E1 enzyme is going to be transferred onto our E2 enzyme. So, let's draw this on the next page then. Let's go over. What's going to happen is our E2 enzyme is going to end up with the ubiquitin group stuck on the side of it, so it's been degraded to a box for some reason, but never mind. So here is our carboxylic acid group linked to our ubiquitin protein here. Well, it's the terminal carboxylic acid group of our ubiquitin protein. Okay, whoops. Right, so here is our ubiquitin protein. And then here is our E2 enzyme, our ubiquitin conjugating enzyme, which now has this ubiquitin group stuck onto its thiol group. So this is E2. Okay, and E1 now goes off with its restored thiol group, basically. So E1, remember, stood for ubiquitin activating enzyme. Well, it doesn't stand for that. It wasn't like shorthand for it, but it was the notation we were using to denote a ubiquitin activating enzyme. So here's this ubiquitin activating enzyme, which has done its job now. All its role was to help the ubiquitin conjugating enzyme to add on this, have this ubiquitin group added onto it. Okay, now what's going to happen is that E2 is going to bind to a final protein known as a ubiquitin ligase enzyme. So ubiquitin ligase, and if you were just to learn this pathway in short, the ubiquitin ligase enzyme is the important one. This is the one you'd learn. Okay, so ubiquitin ligases are denoted E3 enzymes. So basically what happens is, if we draw our E3, or our ubiquitin ligase enzyme, and again, there isn't just one ubiquitin ligase, it's a whole bunch of enzymes. There are loads of ubiquitin ligases out there. So we'll denote this ubiquitin ligase in green. Okay, and basically what it's going to do is it's going to bind to this ubiquitin conjugating enzyme here. So here's our ubiquitin conjugating enzyme, which has now our ubiquitin group stuck off here. So this is the ubiquitin conjugating enzyme with this. So the ubiquitin conjugating enzyme, or our E2 enzyme, binds to E3, the ubiquitin ligase enzyme, and they form a complex. Okay? And now what E3 is going to do is it's going to grab the substrate. So it's going to grab this polypeptide, which is being fed out of the translocon here. So let's say this is the translocon in the ER membrane. So here's our polypeptide misfolded in there. Okay, so let me colour in this translocon in that turquoise colour again. So here's our translocon feeding the polypeptide out of the ER lumen into the cytoplasm. And now this ubiquitin ligase enzyme is going to come and bind to it. And let's say here is our lysine group off here. So do I dare try and draw it? I don't think it'll fit in. So what I'll do is I'll draw its skeletal structure. That's a good idea. 1, 2, then it has these 4 carbons coming off it. And then finally, the final structure here is this amine group here. So that's supposed to represent our lysine amino acid here, which we might denote as K. But remember that K is just the single letter code for lysine. Okay, right, so 1, 2, 3, 4, yes, that's fine. What we're going to now do, what's now going to happen is that the ubiquitin ligase enzyme is going to catalyze the movement of this ubiquitin group then onto the lysine. Okay, so let's draw out the picture and then finally complete the pathway. Okay, so here is our translocon. Okay, so this is the translocon in the ER membrane, and it's still feeding out our polypeptide. And I think we should colour in the polypeptide as well. Let's have it in this pink colour here. Okay, so there's this polypeptide. So here comes our polypeptide here, being fed out of the translocon, which is in this turquoise colour here. Okay, and now bound to the polypeptide is this ubiquitin ligase, or E3 enzyme here. So this is our ubiquitin ligase, E3. Okay, in light green colour here. And then in orange we have our E2 enzyme mounted on top of our E3 enzyme. Okay. And then what it's done is it's transferred this ubiquitin carboxyl group onto this amine group, and then taken the hydrogen off one of these amines, off this amine rather, and put it back onto the thiol. So you regenerate the thiol group here, okay, and now this lysine, 1, 2, 3, 4. And now let's draw it up here. You've got this amine group here, and this is now linked via an amide bond to our ubiquitin protein here. So this is ubiquitin, UB for short. Okay, so let me bring this up here. Right, and ubiquitin used to be coloured in blue. For some reason it lost it. It was demoted in this picture up here. Okay, so now we've got this ubiquitin group on our lysine residues. And this won't just happen to one of the lysine residues. This will happen for a whole bunch of them. So the protein will end up covered in ubiquitin groups. And now once it's got ubiquitin groups on, it's going to be recognized by the proteasome of the which is in the cytoplasm. Now proteasomes are rather formidable things in the world of proteins. So here's a proteasome. A proteasome is effectively a tube, and I always think of that film Chicken Run whenever I hear this. So in the film Chicken Run, I remember Mrs. Tweedy saying, you know, chickens go in one end, pies come out the other end. This is kind of, that was the chicken pie machine. The proteasome is kind of the equivalent for proteins. Proteins go in one end, and amino acids come out the other end. So this is a proteasome. Okay, so the protein, this protein that now has these ubiquitin groups on, so we'll show it here, here's our protein with its ubiquitin groups on, is going to be taken into the proteasome, and it's going to be broken down into its amino acids. So you're going to destroy this protein. It's going to be depolymerized effectively back into the monomer constituents, the proteins. Okay, and that's how the endoplasmic reticulum activates degradation of proteins that are folded incorrectly, and this is the ERAD pathway, the endoplasmic reticulum activated degradation. Okay, so that's all for this video.